Okay, for this video, we're going to be looking at inequalities. So inequalities. Now, when we're talking about inequalities, we're talking about things that are not equal. So when we were talking about equations, we used the equal sign. But with inequalities, that means we are not equal, so we don't use an equal sign. What we use would be our greater than sign, our less than sign, our greater than or equal to, and our less than or equal to. Okay, so inequalities meaning we're not equal, so we're not going to use an equal sign. We're going to be using one of these other four signs. And we have to remember that when we were talking about equations, we had one answer. When we're talking about inequalities, we have multiple solutions or multiple answers. Okay, so let's take a look here. This says that Caleb has at least $5. So Caleb has at least $5. And when I'm thinking about this, I want to think about what this looks like here on a number line. Okay, so I'm just going to say, okay, this is 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, if Caleb has at least $5, that means that Caleb can have $6. Caleb can have $7, $8, $9. So we know all of these are going to be a solution that works because he has to have at least $5. Caleb can also have $5. Okay? So if we were to graph this on a number line, we're going to put a dot, a closed circle at 5, and an arrow going through all of our possible solutions. If I was to write out this inequality, I'm going to say Caleb, which is C, has to be greater than or equal to 5. Because he has to have at least $5, 5 or more. So I could plug in a 6. Is 6 greater than or equal to 5? Yep, that works. I could plug in a 7. Is 7 greater than or equal to 5? Yep, that works. I could plug in a 5. Is 5 greater than or equal to 5? Yep, that works. Okay, so I can see that I have a dot with a closed circle, meaning 5 works, and anything to the right of that works. So my arrow goes to the right. Let's look at another example here. Tim has more than $5. So Tim has more than $5. So I'm going to start here with my inequality. So Tim, I'm going to say is T. Tim has more than $5. So Tim has to have a greater amount, or greater than, 5. So if I go through and do my number line again, I'm going to think, okay, what works here? If I plug in what works, 6 works, 6 is greater than 5. 7 works, 7 is greater than 5. 9 works, 9 is greater than 5. Does 5 work? Is 5 greater than 5? No. So what that means is everything right up until 5 is going to work. Everything on this side of 5 is going to work. So my arrow is going to go that direction. But instead of having a closed circle at 5, I'm going to have what we call an open circle at 5. That open circle tells us everything right up until that point works, but that point where that circle is at doesn't work. Okay, so I'm going to have an open circle at 5, my arrow going to the right, meaning any solution, anything to the right, is going to work with that inequality, or is a solution to that inequality. Let's look at our next one. Vanessa has at most $5. Vanessa has at most $5. I'm going to start with my inequality here. Okay, Vanessa, I'm going to say is V. If Vanessa has at most $5, that means the absolute most she can have is 5. But she probably has something less than that. So I'm going to say V is less than or equal to 5. Now, to graph that on my number line, okay, here's my number line. I have to think, okay, what can Vanessa have? Well, if Vanessa has 4, is 4 less than or equal to 5? Yes. If Vanessa has 3, is 3 less than or equal to 5? Yes. If Vanessa has 1, is 1 less than or equal to 5? Yes. What if Vanessa has 5? Is 5 less than or equal to 5? Yes. So that's telling me everything on this side of our 5 works. So I'm going to have an arrow going that direction. And because 5 works, I'm going to have my circle of 5, but my circle is going to be closed. The closed circle means that point also works. Okay, that point also works. So 5 and everything to the left is a correct solution. Let's look at another one. Jenny has less than $5. Jenny has less than $5. So again, if I start with my inequality, I'm going to say J for Jenny. Jenny has less than $5, meaning Jenny has to have a smaller amount than 5. So if I look at this on my number line, okay, I'm going to think about, okay, what can I plug in here? Will it work? If I plug in 4, is 4 less than 5? Yes. If I plug in 3, is 3 less than 5? Yes. If I plug in a 6, is 6 less than 5? No. Okay. If I plug in a 5, is 5 less than 5? No. So what that's telling me is I'm plugging in solutions. I'm saying that everything on this side of 5 is going to work. So my solutions are going to the left. And everything right up until 5 works. 5 doesn't work because 5 is not less than 5. So I'm going to use an open circle at 5. An open circle at 5. Okay, so we have a word problem here. It says, Kelly works for Lube Stop. If a customer waits longer than 20 minutes, they are not charged. So if they wait longer than 20 minutes, it's free. The fastest oil change Kelly has ever done took 6 minutes. Show the possible customer wait times in which the customer is charged. So we need to show all the possible solutions for which a customer is charged. So the first thing I'm going to do is I'm going to come up with my number line here. Alright, here's my number line. I'm going to count by 4s. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. And so I'm going to start taking this problem step by step or piece by piece. If a customer waits longer than 20 minutes, it says in the second sentence, they are not charged. So I know if I'm trying to graph for what they are going to be charged, I know if the number is greater than 20, they are not going to be charged. So if they're hitting 20, they're charged. But anything greater than that means they're not going to be charged. So 18 works, 16 works, 14 works, going this way. Okay, so I know I'm going that way on my number line. But then it goes on to say, the fastest oil change Kelly has ever done took 6 minutes, meaning Kelly's not going to be able to go any faster than 6 minutes. We're not going to get any times less than 6. So 6 and going up is how long it's going to take. So looking at this, I can see that anywhere in this red section is how much the customers, or what times the customer would be charged at. So between 6 and 20 minutes, the customer is going to have to pay. So from that, I can write out an inequality. I can say, all right, I'm going to start with my variable x. And looking at the left here, I know that x is going to end up being greater than or equal to 6, because 6 is the fastest time that you took. Okay, so it's not going to be anything smaller than that, so I know x is going to be greater than or equal to 6. So 6 is less than or equal to x. But then I also know that in order for the customer to charge, it has to be less than 20 minutes. So x also has to be less than or equal to 20. So I ended up with this really long inequality. At 6 is less than or equal to x, which is less than or equal to 20. Now there is a trick to help us remember whether the circle is going to be an open or closed circle when we graph these on a number line. if our circle is closed, that means we're using the sign less than or equal to or greater than or equal to. Okay, anytime we have a closed circle, that means that point is also included, so we have to have the or equal to's. If we have an open circle, that means we just have the less than sign or the greater than sign. So you always need to be thinking to yourself, is the number in our inequality, does that number actually work in the inequality? If it does, then we're going to be using the closed circle. If it doesn't, we're going to be using the open circle.